was going to go easy on you, not to hurt your feelings. But I'm only going to get this one chance. Something's wrong, I can feel.
Hopefully you remember that proportions are two ratios set equal to each other. That one is review, but we're going to use proportions today to solve similar figures for a missing side. But first we need to talk about what a similar figure is. I have a picture of two of them down here. Let me move that up. Similar figures are two objects that have the same shape, but not necessarily the same size. And I'll give you a minute to write that down. When figures are similar figures, they're going to tell you that they are. You're not going to have to guess. And they'll tell you with this little symbol like that. And that means that one object is similar to another. And I'll show you how we write that in a little bit. But the point is that when you have similar figures, you can set up a proportion to solve for an unknown side. Let's look at these triangles a little bit closer. And I will color coordinate what I'm talking about. These are similar figures, I'm just going to tell you that. And I can say the side 3 is proportional to that green side 6 in the second triangle. So what I've set up here is small triangle over large triangle. And that ratio will be equal to, let's go for the red one here, that 5 over the x. Again, I set it up in the same order, small triangle over large triangle. And you can go ahead and cross multiply this to find an answer. And so you would get 3 times x equals that 6 times 5, this one right here, which is 30. And so x is going to be 10. So we can say right here that this side is a length of 10. And you can kind of see that that makes sense because going from this side to this side, obviously we multiplied by 2. And the same thing happened when we went to 5 and then suddenly got 10. Now you can do it again with the blue side, and to set up a proportion you can use the green corresponding sides, those means the sides with the same position, or you could have used your red numbers there to fill it in. But again, I did small triangle over large triangle, and then I'm going to do small triangle blue side over large triangle Y. And you've set up this proportion and you can solve it. I should mention it does not have to be small triangle over large triangle. You could have also done large triangle over small triangle. Just make sure you do it that way all the time then in your problems. And there you can solve for unknown sides. Here we have another set of triangles, and I will tell you that they are similar. They have the same size but not the same shape. And as soon as you are told by directions or me verbally that they are similar, you're allowed to set up a proportion to solve. The trick with this one is you have to be careful. Sometimes you have to shift shapes around in your head to make sure that you have the right sides set up and that they're corresponding. So this 5, this position of this line, really corresponds to that 9. This figure seems like it was just flipped or rotated, but nonetheless these red sides correspond, the blue sides correspond, and the green sides correspond. So to set up your proportion, we'll solve for the green ones first. You'll take some information you do know, and you know the short side of the small triangle 5 is proportional to the short side of the large triangle 9. And we were going with the green sides, so I will take the small triangle length 12 over the larger triangle unknown value of x. And now you have a proportion, and we'll cross multiply to solve. So I will take my 5 times my x, which is 5x, and that equals 9 times 12, which gives you 108. Okay, and then when you divide 108 by 5, you're going to get a decimal, and that's okay because that happens a lot in math. Things aren't perfect. So 21.6 is the length of the X up here, so I'll color code that. All right. But we still need to find our Y. So I'm going to stick with our red ratio of 5/9. And the blue one becomes the 13 over the Y. And cross multiply again. You get 5Y equals 13 times 9, which is 117. And then dividing both sides by 5, you end up with 23.4 being the length of the blue side. Your shapes don't always need to be triangles. They can be any figure as long as you're told that they're similar. And so we have two rectangles here, and I'm telling you they are similar, and we're going to find out how long Z is. You may already know just by logic, but we're going to practice setting up ratios for when these problems become more difficult. So your job is to figure out which sides actually correspond, and it's pretty easy since I color coordinated these with with red and blue, but that, you're going to get worksheets that are black and white. So this short side is going to correspond to the larger rectangle short side. So you would say 2/6 will set up that proportion with the smaller rectangle over the larger one. Cross multiply again and divide by 2 to see that Z, or this side, is 15, which you could have checked with mental math as well to see that 2 times 3 got you the 6, and so 5 times 3 would give you the 15. So I want to spend a quick second on naming triangles. This is really a geometry concept, but you'll see it a lot here. And when you have triangles, you're going to use capital letters to notate the corners of the triangle, or the vertices, which is what they're called. And I'm going to color coordinate here again. And so we're going to use capital letters A, B, C, and those are just notating these vertices. When I'm going to use 3 different letters for this smaller triangle. And I color coordinated again, but eventually I'm going to stop doing that. Okay, so when you see a triangle listed, the way they're going to write it is triangle ABC. That means triangle ABC. And if they're telling you it's similar, they're going to throw that little symbol in there that means similar, but then they're going to write these letters in the same order that correspond to the first triangle. So because A came first in the first triangle, D will have to come first when I write down that letter or that vertex there. And then B came second, and B and E are the corresponding vertices, and so I'm going to have to write E second and then F. So the order that these are written are very important because they're giving you a clue about which corners go with the other shape's corners. And here's an example of what I mean. We are told that triangle FGH is similar to triangle KLM. So I'll point on the figures that FGH is similar to KLM. And so because the way it is written, F and K are corresponding vertices, and G and L are corresponding vertices, so those go together. So when they ask you to find LM, they're asking you to find this side. In this case, they're asking you to find X. And so when you set up your proportion, and this one's pretty easy to see because the figures set up, they look in the same orientation, but we'll start with our smaller triangle, and so we will say FG, which is 32, this is FG, which is 32, over the larger triangle's corresponding side, KL, is 24, and that is proportional to this side, GH, which is 20, and to complete the proportion I will put the unknown value X there. So you've just set up your proportion properly, And it's really not that big of a deal, and I don't mean to make it sound like it is. I just would rather have your foundation super solid. So you have 32 times x equals 20 times 24, which is 480. Okay, so that's using cross multiplication. And then when you divide by 32, you've solved for the unknown side x, which is 15. And so this length here is 15. I would like you to try to solve this triangle for x, that side length AB there, and remember to use the way the triangles are written according to their vertices to help you make sure that you're doing it the right way. So go ahead and pause the video now. Now you can see the way I've set up my proportion. Yours might look different, but as long as you kept your corresponding sides in the right positions, you'll end up with the same answer. And so hopefully you did do it differently to give yourself the confidence that you can do these different ways. Here's a common figure you'll run across, and these are two triangles superimposed over each other. And you're going to need to be able to see both of them. They tell you that you have a triangle TVU in there. So here's TVU. That's the big one. Then they say it's similar to triangle QPU. So here's QPU. That's the smaller one. And if need be, go ahead and just redraw it outside. Don't let them mess you up by getting you confused over the shape. This is that triangle QPU. And now they want you to find x. Well, x is right here. It's this triangle side length right there. And when you can see it brought outside of the superimposed figure, it's a lot easier to figure out how to set up your proportion. So let's start with the bigger triangle. And I'll just start with this side length 6. And we know that that corresponds to the x that we're looking for. And now this might be a little trickier to see, but it's this whole side length here. Because this was 4 and that was marked 4, this whole side length is 8. So that's going to go up here. Maybe I'll write a little 8 there for you. And that corresponded to 4, this side length over there. So you've set up your proportion. Now go ahead and solve it. This is the icing on the cake. Then dividing by 8, and you'll see that x is 3 right here. And this one you can check using logic too, because this side was half of that side, so this 3 is half of that. But make sure you're showing your work so that you understand how to set these up. Now here's the icing on the cake of why we use similar figures and proportions to solve for unknown sides. Because there are a lot of shapes in real life, like a tree or a building, that are just way too tall to maybe measure. And so we can use similar figures to do that. And a lot of times you look at the shadows of things. So if your sun was up here, it's going to create a shadow. The tree creates a shadow, and this little dude standing there creates a shadow too. And it says, like, if you know how tall this guy is, and here they say he's 5 foot tall, and his shadow was 7 feet. So the 5 foot tall man casts a shadow of 7 feet. And the tree casts a shadow of 20 feet. And they want to know, how tall is this tree? So you really have two triangles here again, and they are similar because they share the same shape, being that of a triangle. Okay, so, whoops. Try to erase that. That's not going to happen. Okay, so let's draw our two triangles. Here's my man. He was 5 feet tall, and his shadow was 7 feet. And my other triangle is larger. It was the tree, and its shadow was 20 feet, and I'm looking for the height of that tree. So you can notice that I ripped the two triangles apart again, and now you need to set up a proportion. So I will say the height of the man over the height of the tree will equal The same thing as the shadow of the man over the shadow of the tree. And now you're going to multiply 5 times 20 to get your 100, and 7 times x gives you 7x. Divide both sides by 7, and you end up with the height of the tree, which was 14, and I'll round to the 10th place, 14.3 feet. You certainly don't want to get up on a ladder and measure that thing. And so similar triangles is super helpful in safely measuring the height of tall objects.